Hello. I'm so happy to be able to welcome you to the next edition of our Nodes 2020 extended session of community events where we can learn about the really interesting work that's happening all around the world as part of the Neo4j community. If you haven't tuned into these sessions before, um, my name is Nathan Smith, and I am a member of the Neo4j community and the organizer of the Kansas City Graph Databases meetup, and so happy to be with my friend Lou Lazarevich, who is part of the Neo4j organization, and we have a wonderful guest here today of Otávio Calaça Xavier, who is going to present to us, and the Nodes Extended has just given us a great opportunity to continue all of the learning that we had in a packed day of events and sessions last month. And now we can hear from even more speakers and a little bit less of a fire hose of information all at once, where we can have a chance to discuss and to share together as a community. And so I'm just really thankful that you're tuning in and joining us, and I look forward to the sessions today.
Yes, thank you so much. Yes, super excited. We have an amazing series of talks coming up. We had an amazing talk last week. We've got an amazing talk today. And, you know, as we've been scheduling, we just go, wow, there's so many interesting things to come and see. So stay tuned. We do have the schedule. So I'll post a link to the schedule that we have so you can have a look at what else we've coming up and what dates and times. Just a quick note. So please ask your questions of the talks. Oh, we've got somebody from Brazil as well. Fantastic. So if you've got questions, do ask them. And what we're going to do is at the end of our sessions, we're going to have a panel talk. So we'll bring your questions then. And yeah, let's roll. So without further ado, over to you, Otávio.
Thank you for having me today. And we will talk about analyzing open public data of Brazilian companies and their partnerships in a graph database. So before starting, let me present myself. So I am currently a PhD student here in my country, and my main areas are related to deep learning and graph representation learning. And also I am a researcher in SEA, which is an artificial intelligence center here in Brazil. I participate in some communities such as Deep Learn Brazil and Data Train. For the ones who are Brazilians, please take a look on those communities. They are really great. Currently, I am a professor in our local university and also in our local technological institute, so UFG and IFG. And also I am constant in machine learning, software architecture, and DevOps. So if you need to reach me, please, you can contact me using this code name, this nickname, Otávio CX. You can reach me in Gmail, Medium, GitHub, LinkedIn, all the stuff. I have always this nickname. So yeah, the agenda for today is I will talk about first the Brazilian open government data. So here we have an initiative to share, to get all the data related to the government open. And I will talk about that. Then I will talk about an architecture that we developed to ingest some of those data to Neo4j. So the proposal of this architecture is to have a graph of companies and their relationships, and with that we can do many things. So let's see. And after this explanation, I will talk about, or we will see some queries and data visualization in Neo4j, and then conclusion and future works. Okay, so let's start with the Brazilian open government data. Currently, we have a portal dedicated to this data. So the Brazilian federal government provide us at least 9,000 data sets in this portal. So this dados.gov.br you can see all the data sets we have. And also, here in Brazil, we have an initiative, non-governmental and non-profit, to try to organize those data sets because they are, placed in many formats and not so usual formats. So the Brazilian IO is trying to organize this stuff in using, commercial formats like CSV and database and things like that. So please take a look. It's a really great job. And also each state or city, for instance, in the case of the bigger cities, we have their portals too, with some data related to specifically the state or the cities. But today we will mostly talk about the open government data from federal government. So yeah, inside those 90,000 data sets, we have one related to the companies here in Brazil. So the Federal Revenue Service puts there a data set with more than 50 million entities and more than 30 million people, the owners of those entities, and all the companies, all the associations, the institutions that we have here in Brazil are there. So we can see, for instance, the address, the relationship between the owners and the companies. And for instance, in some case, an owner for a company is actually another company. So we can, create this graph with all the related companies and so on. But for the people, I mean, for the individuals, we don't have so much because the personal data is not being exposed. So for such people, we just have the name. For instance, if a company have a person as an owner, we have just the name of this person. Yeah, okay. So the data there is like this one I've pasted here. So it's not CSV or anything, easily to understand. It's a positional textual file. So each field inside the file has a fixed size, I mean, a fixed number of characters, and we should respect it. So the first thing we need to do with those files is to try to convert them to something that is easier to work with. And this is our pipeline, the ingestion pipeline. We first have this legal entities open data, similar to the one I showed in the previous slide. And the first thing we do is to try to convert them, for instance, in CSV. But since we have many companies and many people there, we use scalable architecture. So we have first something converting those entries in objects and then persisting them in a RabbitMQ query. Then another process get these objects and persist them in a PostgreSQL. So with that, we can, for instance, if for some reason this task that that put the data inside the PostgreSQL, if it, for instance, turns down, we can still continue converting the data from the text files and putting them in the query. And we can also start multiple tasks here according to the necessity. So it's really an interesting architecture since we have this kind of distribution. But why we are persisting first in Postgre to then persist in Neo4j? It's because some queries are related to tabular data. So we don't really need to have all the power of Neo4j related to graphs. So we first persist those data in PostgreSQL and then extract some CSVs already in the format that Neo4j admin supports. So we have this task that queries the database and create those files to be imported in Neo4j. So why we are using Neo4j admin and not other tool here, for instance. It's because of the size of the data set. So since we have a lot of entries, Neo4j admin is really fast to do such kind of task. So that's why we choose this approach. Okay, so let's talk about the hands-on. It's a really simple presentation here just to show the power of this data and the power of using a graph database with such kind of data. So yeah, so to do that, I've decided to select only a part of this data, so not all the companies, but only the companies here in my state. And I am in Goiás. So here we have 1.5 million companies, almost, and 1 million people related to those companies. So they may be the owners or representatives of the owners. So for instance, if we have a young guy or a teenager as an owner, we also have the representatives. So the father, the mother, or something like that. And 246 cities. So all the cities from this state. For the ones who don't know this state, it's the most centralized state here in Brazil, and where the Brazilian country muse was born. So if you know about the sertanejo music, it's related to our state. And also we have great waterfalls, caves, and thermal water. So I just put some picture here just to get you knowing better our place. Okay, so and for you that don't know where is it, we have here Brazil in Latin America, South America, and Goiás is here inside the center of Brazil. Okay, so let's go back to the hands-on. So for this presentation, I prepared a schema like that. So I have the company and some relationship with the company. So we can have a company as owners of another company, or we can have a foreign, for instance, a foreign company or a foreign person as the owner of the company, and also a person. So someone really individual. So yeah, and also where the company is located. In this case, the city the company is located. So I'm trying to have something simple here, just to show you the power of having this data in a graph. Okay, so let's go to the database now. And we can see here we have 2 million, a bit more than 2 million nodes, and a bit more than almost 2.5 million relationships. So those are all the companies here in my state and all the relationships they have. And let's try to query something here. So for instance, I've prepared some queries. Let's try to something really small, just to try to get a relationship between the person and the company. So we can see here. And what is really grateful in this presentation, in this visualization, is that we can try to analyze data not only with queries. So we can, for instance, navigate in this visualization. So in this case, we have this company called Banco do Brasil, which is a really common bank here in Brazil. And we have a person as owner of this bank. So we can see, for instance, the other owners, just clicking here. So, and you can see we have many people as owners of this single company here. And also, where is it? So in this case, the place is Itumbiara. So it's a really great visualization. Let's try another query, a bit more complex. So in this case, I want to see all the companies that have inside the name the word papelaria, which means stationery store. So let's see all the stationery stores here in my state. And also the relationships with the owners. In 1 second. It was faster when I tried it before. Okay, so we can see we have a bit more than 100 companies related to the word papelaria, and we can try to reduce the zoom here just to show one thing for you. So we can see that many of them have just two owners. So, for instance, this kind of relationship. But we also have one that seems to be a group. So many companies being owned by the same people, and it's actually really a group. So all, if you see, all the companies here have the same name. So see here in the bottom. So it's a really great presentation, a really great visualization, because even without having exactly what we need inside the query, we can try to analyze the data using the results of the query. So in this case, I am not putting in the query that I need the most larger group of companies here, but I can see just analyzing the data we have. So just the analyzing the visualization. Let me just try another one. So in this case, I am interested in relationship that have many hops, many owns hops. So a company that owns another company that owns another company, and so on. Let's see if we can run this one. Okay, you see here, so for instance, this company, Nautico, has as an owner this other company, which has an owner, this other company, and so on, until we get in this person, which is Valdo in this case. So what we can do with such kind of queries? Here in Brazil, it's really common to have companies being created for less payment, so to reduce the tax they pay. So if a guy have many small companies, he will pay less than if he has a big company. So that's why people do such kind of stuff. But it's not, let's say, it's not always allowed. You need to follow some rules to be able to do that. And with such kind of query, it's easy to understand if the guy is following the rules or not. So this is an interesting query because of that. Let me just get another one here just to show now the company that who has actually which has most owners. So what is the company that have more owners? Let's see. I am not explaining the queries, but during the questions we can explain them just to be quicker here. So yeah, let's see. In this case, we have a company here with at least 299 person, in this case, people related to the company. So all those green nodes here are owners of this company. So it's also an interesting query because we can see in such cases that some companies really have many owners. So, and in such case, it may be a complex kind of business, or we should know if they are doing the stuff related to tax and all this stuff correctly. So yeah, just to present some queries here. Let's talk about the conclusion. So we could see that Cypher is a really good language because we can really write something that matters for us without doing it in a complex way. So we don't need to write, lines and lines of SQL to have the query that we need. And also we can see that Neo4j browser visualizations are not related only to show the result, but also they are interactive, so we can continue the analysis using the visualization. As a future work, what I am planning to do with this data is first putting more data, for instance, no open data related to revenue and commercialization between the companies. And in this case, we can have a really more meaningful graph, because we will be able to see all the companies that are doing things with the other companies, for instance, selling products, buying products from other companies. And also, we can use graph data science library to get some patterns from those relationships, and also to detect some anomalies inside the graph. So with that, we can do the goal of this project, which is to identify the tax evaders. So the companies that are not paying the tax in the right way. And if we will be able to do that using graphs, it will be great for our government. Just to explain, this project is sponsored by the government, and this is the goal. So yeah, that's it. Thanks for watching my presentation.
Wow. Okay, so over to the panel chat. Thank you very much. That was super, super cool and really, really fascinating topic as well. A very, very relevant topic, I think. So just quickly tidy up some of this. And oh, wrong one. There we go. Cool. Yeah, so thank you so much for that. That was really, really cool. Really, really interesting. I guess the question is, first one I've got before I'm sort of charging in, I'm like really keen. So how many companies in your research so far have you found which have raised, obviously don't name them, but have raised question marks and your sponsor has gone, that's amazing?
Yeah, actually, we have, really interesting situations. Here, I try to, have a simpler explanation of the problem. But for instance, here in Brazil, we have such kind of existentialism. So some people, the government pays some people just because they are poor. And we can see, companies that have a high revenue having those kind of people as owners. So it's really weird. And another example, we can see, for instance, companies that are buying stuff only from a single supplier. So they do all the kind of stuff. But answering your question about the number, I don't have a precise number, but we can say that 3-4% of all the companies are doing things wrong, at least.
Doing interesting practices.
Yeah.
That's really neat. How much data cleaning did you have to do after you received those data from the open data? Did you have did you have some problems with like I know for me, Smith is a very common name in the United States, and the last company I worked at, there was another person named Nathan Smith at the same company, and so we were always getting each other's emails. Did you have that kind of problem as you're working with the owners or the companies, having to clean up data that was a little bit confusing or dirty in some way?
Yeah, we have such kind of problem, and actually we are trying to reduce, or at least to have a better quality in data by having redundant data. So, for instance, the state also have my state, Goiás, also have their data related to companies. So I am getting this data and trying to compare, for instance, the address, the name of people, and all the stuff, just to see if things are right. And it's just an example. So we also have, for instance, here I am in the capital of my state. So almost a half of the companies are here. And we also have data from the open, public data of the city. So we are trying to have this kind of redundancy to reduce, actually to improve the quality of the data. So we are working like that, but it's really a complex work because we have a huge volume of data. So because of that, we have this kind of pipeline trying to have things distributed and things like that.
Mm-hmm. So do you find that the graph is helpful in cleaning up that data and combining from those different data sources, or are you doing that before you load it into Neo4j?
Currently, we are doing before. So we have this pipeline in Python, and we are comparing data there. So for instance, I have, in this case, in this example I described, we have a tree source of data. And before putting in PostgreSQL, we are cleaning the data. But we can do that in other ways. So for instance, we realize that in some cases, having the whole data inside the database is good too, because maybe we can, try. The goal is to try to extract those anomalies, those things that are not right. So yeah, we are changing our process right now to have such kind of approach, but not using graphs yet in this step.
That's great.
Yeah, no, it's super interesting. And I guess that'll be the fun bits of in that journey where maybe you can do some graph-assisted entity deduplication. And I wonder if you start getting some really interesting stories about addresses, and you suddenly discover there's an address. I mean, you said it's addressed to company rather than addressed to person, but do you have addressed to person as well?
Sorry?
Do you have addressed to person as well, or is it just addressed to company? Addressed to owner, sorry.
Yeah, we have currently we have a problem, which is, for instance, I described that situation with the assistantialism, and why this kind of people are owners of such companies, because they are. I'm not sure what is the expression in English, but here we say laranja, which means a person that was paid to do something for other one. So the owner in the papers, the owner in the documents, is not really the one that used the company. It's another guy, he just paid some money to be there. And it's really difficult to understand and to get this kind of situation, because we don't have any, data related to the guy who actually uses the company. So, and we are trying to get data from everywhere, including social networks, to try to find those guys.
Really interesting. So much business today is international business. Are you thinking that eventually this might extend beyond Brazil, that you would be able to bring in data from other countries even?
Yeah, sure. but many countries are not, let's say, with the invoices in a structured way, because right now what we are doing is trying to get the data from invoices to try to understand the relationship between companies, because you have really a great, data inside the invoices. So you can say who is buying, who is selling, what kind of relationship they have, things like that. So, and for instance, some countries, in some countries, the invoice are just a paper, so it's not a stricter thing. So in Brazil, we have this kind of a structuration. So all the invoices are XML files, and I can extract data from there. But answering your question, I think the problem is international. So all the countries face some situation, some similar situation, and we should deal with that. So the only thing that is different is how we get the data. So in our case, we use these XML files, but for instance, in United States, I'm not sure how to do that.
So we've got one question that's come in on the chat, which is it impossible to infer some facts about this graph or in this graph?
If it's possible to infer some facts, it's the question. I'm not sure
like
if I
a
understood.
reasoner. So I assume like is a reasoner. So I assume what they're getting at here is probably something like triples. So presumably somebody is an owner or somebody is a director. I think Veraza, if you could provide a bit more around that question, that'd be great, and we'll bring it up. But I guess a really fascinating thing that you talked about, discovered new facts. I guess you have. You showed that earlier.
Okay. Yes. For instance, suppose we have a company. We really found a company that is doing things wrong. So it's not paying the tax correctly. We can get the owners of this company and try to investigate if the other companies from those guys actually are doing the same. So we can do such kind of analysis.
I guess because you gave the example earlier, didn't you, where you said, I guess you do, because you have similar tax breaks in many countries around the world, where if you're a big company, then you pay X taxes, whereas if you're a small company, so if you're under an enterprise license or a startup or whatever, opportunities you get. So if you're below a certain size, then you get tax breaks or you pay less or whatever else. And I think you were inferring with one of the examples where you've got certain situations where company owns a company owns a company owns a company, and those two companies in the chain, it's like a beautiful linked list. It literally is a linked list because they only ever deal with each other in the company. And you're probably going there, well, hang on a minute, this is a bit interesting. That company never deals with anybody else but that company, and so on. Yeah. So I guess that's a great example of how you're inferring.
Yeah, and it's really a common situation, and it's really hard to get in a relational database because you don't have such kind of relationship. So you can see there in 2 million nodes, it was really fast to identify a relationship, this kind of path in the relationship.
I think that's and this is a real testament to the structural difference of how the data is stored in a relational database versus a graph database. And whilst a relational database, tabular database, it's absolutely fantastic for running straight down the column to do stats on that value. When you start thinking about self-referencing or joins, you have to have some kind of a hypothesis as to how many joins you're looking for and then write your query to deal with that. Whereas just due to how you're storing the data is completely different than a graph database where, to go off and do stats on the property across, a billion node graph is going to be quite a painful query. But if you want to know, is there a path between two nodes, or you want to do a pattern where you're saying, well, find me a path, that's easy. That's Christmas lights.
Yeah. Mm-hmm.
just follow each node, follow each little light on your Christmas lights, and off you go. And I guess that, and in this kind of thing where, as when you're talking for this example, it reminded me a lot of the Panama Papers, the Paradise Papers, the Swiss leaks, all the other ones where it was just due to just storing your data in a different way because you're looking for the connections, and you don't know how long those connections are going to be, but you're just going, well, as long as it's connected, we're going to find it. And yeah, it's very reminiscent of this, isn't it?
Yeah, I would say, that's why we have the two ways of storing data. So we have the graphs, but also we have the relational database, because some kind of queries are better in the relational database if it's only related to the company itself. But when we need those kind of paths inside the graph, it's really a painful thing to do in relational database. So yeah, we can, for instance, classify the companies according to their features, to their properties in a relational database. And I think it's most recommended to do it there, not in Neo4j, for instance. But when you have such kind of problems, that is related to relationships and such kind of stuff related to graphs, Neo4j is really better than a relational database.
Yeah, it is super, super cool.
So yeah, there is no, how to say, the solution that do everything. So in a real problem, you will need to prepare a pipeline with many technology, many for instance database and all this stuff to have the problem being solved. So
right tool for the job. Right, you use and that's the whole sort of thing around polyglot persistence, is you pick the right data store for the job, you pick the right tool for the job, you pick the right framework for the job. It's interesting as well that you're using RabbitMQ. So is that the case of you're looking to queue up jobs as data is being processed and they get pulled in, or a bit more about that?
I'm not sure if I understood the question.
So, you talked about you using RabbitMQ as part of your stack to process the data. So were you using it as a queuing system? So you were processing, so using it as a queuing system. So you grab jobs to process, and then as they're ready, they're dropped into a queue to be pulled into Postgres.
I'm not sure if you are still seeing my presentation, but that is the pipeline again. So we are currently using RabbitMQ just to distribute the work. So in this case, I can, for instance, this first task, which extracts the data from the plain text inputs, it can work alone, so itself, and then I can have many machines or many tasks running the next step. So that's why we are doing that. And also, if anything happens, any problem happens in any of those steps, we are not, we don't lose data. So it will just stop, and we can continue working with the other one. And also in different environments, I mean, different machines. So I think it's really great to use some query or messaging system to have such kind of pipelines, because you can split the work in many machines. You can, do something more reliable.
Yeah, no, and it's a really nice idea, because I like that, because as you're saying, it's obviously if something happens with the queuing system, you can still revert back doing the sort of your more traditional ETL and then pulling it into database. But this idea of you can start queuing up a lot of things and you can start putting things in parallel. So maybe you start having parallel ingestion processes and things like that. So yeah, no, absolutely, very cool.
Yeah.
How frequently are you planning to refresh this data? Is this a process that you get new data every day, or is it more
I didn't
once a
talk
month or
about
something like that?
it in the presentation, but this data set we are using, the main one from the federal revenue, uh, it is being updated each quarter. So, I mean, every quarter we have an
Mhm.
update of the data. So, but we also have other, data sets. I mentioned the data set from the state, the data set from the cities, and they are more frequently updated. So what we are
Mhm.
doing right now is creating in this pipeline, we are creating a process to update instead of just persisting data in the database. We are having a bit more complex pipeline, which is to update the data that we already have, and we are using, uh, let's say, temporal feature of Postgre to do that. So Postgre have a plugin to do such kind of stuff. So we can say, put this entry there, and then if I say put this entry there again, it will get only the difference, and it will store the difference in the table, and in another table it will have the change log. So what was the previous how to say the previous value there. So
Okay.
we are sorry,
Sorry, go for it. Sorry.
we are doing that right now. So because it's really hard to to do all the ingestion again, for instance, every week. So we are trying to update
Mhm.
only the companies that really change it, and also to insert the new companies. So that's the approach. But we are doing it right now each week, because actually every week, because we have those other data from state, from cities, not only the one from federal government.
That's
Yeah.
great. So then when you load it into Neo4j, you just take the most current version of the data to use with your Neo4j admin import, or do you actually bring in the history of changes as well into the graph?
Yeah, yeah. We are not doing it right now, but it's sure a great idea. I will try to do that.
Yeah, I guess it would be really, really interesting to see. If you start looking at rate of change as well as change, so do you have certain companies that change a lot? So all of a sudden, lots of companies keep sprouting up and then sort of, go disappear. Because I think that's the one that happens a lot in the UK,
Yeah,
where companies seem to only live for up to 1 year and 364 days, and then a new one turns up with the same director.
yeah.
Mm.
It really happens.
Very nice. Well, I guess I will to everyone watching. If you've got a question, here is your last opportunity to ask your questions before I guess we wrap this fantastic session up. So if you've got any questions, drop them in the chat. We will relay them. I guess it's very exciting stuff. So I'm just trying to just. So you what next? So are you currently working on the next stuff? So graph data science, that's a really hot topic. So when are you going to start doing some work around that and incorporate that into your work?
Yeah, actually, I am currently studying the graph neural networks, which are, they try to get patterns from the graph. And what is great in this kind of models is the fact that they get as an input a graph. So instead of you having a table or a vector as a input, you have a graph. And we can, we don't need to transform the graph in, for instance, an adjacency matrix. You just use the graph and have the pattern being classified. So yeah, it's a really great you know kind of model, and I'm trying to use them right now with the data we have.
Hmm. Cool. It'll be fun to
Yeah.
see updates on this. So as you progress and you start introducing new
Yeah.
data sets, and certainly the new data sets, and I know you talked about looking at getting company accounts and sort of incorporating that. So I think that'd be very fascinating to see, obviously, with the public data sets that you're allowed to share and share your progress. It'd be really, really fun to see that. So I'm going to. I've asked many questions, so I'm going to stop there. So if there's any more, otherwise, I leave the final word to you.
You know, I just wanted to follow. As we've been talking, it's really triggered my memory of a talk from Nodes in 2019 from Daniel Belchior about the public prosecutor's office in Brazil using Neo4j. Are you related to that work at all?
No,
Are you
not. I
familiar
am
with that work?
familiar, but not. It's a different work. Yeah.
Okay. That was a really interesting talk too.
Really great. But
Like
in our case, I am from the university. Let's say doing a job for the government. So I'm not really a person from the government. So I'm just trying to improve their patterns, trying to improve their process, and they are sponsoring us to do that. So yeah, but for instance. Maybe in future I will be in another project, so it's just a project related to this problem we have there. So I'm not actually public how to say employee.
Okay, it's nice to see the academic and the government collaborating from different perspectives on similar types of issues.
No, absolutely. Wow. I think we will leave it there. Thank you so much, Otávio. That was absolutely brilliant. Really, really great to see what you're doing. This kind of thing I always get excited about because, it's amazing what you can find. It's for the common good, and it's really heartening to see this kind of thing. And thank you so much for coming and presenting with us. Thank you so much to you, Nathan, for joining me once again and being a co-host. Very much appreciate it. And thank you to you all for joining us and
my pleasure.
Coming along and bringing your questions. So, another fantastic Nodes 2020 extended session. And we will be back next week on the 17th. So please join us then. Thank you very much. Bye.
Thank you, guys. Bye.